Welcome, student council members and people that just chose to skip Thursday. We are going through 22 and 24 for sure before we start some notes. All right. So 22 said, here's a polynomial. This is going to take so long just to write it. There's a polynomial right there. It's equal to 0. And then it said there's two roots, -2 and 3. We're going to see what you guys did with this. All right, so I'm going to do a -2 first. Oh, it's okay. Come on in. I'm just recording. Now another student just walked in with the pass for Kaylee loss. Not until later. You must wait. Okay. All right. 4, -4, -25, 1, and 6. Are there any powers missing to the fourth, to the third, to the second, to the first, and a number? No. What should my answer be? What should my remainder be? It said it was a root, so what should my, it should be 0. Okay, so 4, -8, -12, 24, -1, 2, 3, -6, magic. Now, here's the thing about this problem. Some of you guys tried to then write that as a polynomial and then factor that. I don't know if that works. We're going to find out. So then what you're really supposed to do is take the other roots, which is 3, and now go into this answer without the 0. Okay, so now go in there, and if it works, which it has to because it said it was an answer, my remainder here should be 0. Let's find out. 4, 12, 0, 0, -1, 0. I don't know. Let's find out, because I think I saw on Loss's paper the right answers anyway. Did you have plus or minus a half?
Yeah.
Okay.
Like, but whenever how I did it, I also got the 3 and the -2, but with the opposite.
Yeah.
Wait, where'd you get the 3 from again?
It was given in the book. Okay.
See, I forgot that one. And then I tried doing them both, and I was like, well, now I can't back to them.
Right. So some of y'all may have took the red answer and did grouping, right? Some of y'all might have taken the red and tried grouping. And so I guess that would work, right?
Yeah.
Okay. But really, I think maybe this is what you were supposed to do. This would be 4x squared minus 1. Hello, 4x squared minus 1 equals 0. So that would be 2x plus 1 and 2x minus 1 equals 0. So then x is plus or minus a half. There's no need to test that because there wasn't anything we had to worry about on number 22, was there? No. But that's interesting because I've never seen the grouping method used and it actually worked.
Well, I don't think 24 works.
No, this one definitely did. Okay, so that was the double deuce, right? Number 22, the double deuce. Can we move on to 24? Well, let's find out if it works or it doesn't. Oh, wait, is this the one that's imaginary?
Yeah.
Well, then obviously. I don't know. Maybe I didn't either. Spoiler alert. Maybe I did. Let's try it. Here we go, everybody. I'll do it the way that I just did the previous problem, okay? So -1's an answer. And it's going to go into 1, -2, 1, 0. Did you guys remember the 0? And -4. Did you remember -4? Did you just write 4? Tricky, tricky. So if this puppy works, it's going to be 0 for the remainder. 1, -1, -3, 3, 4, -4, -4, 4, 0. Yippee skippy. Now the next step 2 is an answer. So I'm going to take 2 and I'm going to go, and I'm going to go 1, 2, negative 1, negative 2, 2, 4, 0. Yay. So this is x squared minus x plus 2 equals 0. You can't factor that. Do you guys know why you can't factor it? Because a minus plus is a minus minus. You can't factor that. So if you thought it was 2 and 1, gotcha. So, oh shucks, I've done that before. How do I get it back? No. There, never mind, nothing. So I have to do quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's 1 plus or minus square root of negative 7 over 2, which is 1 plus or minus I root 7 over 2. What great answers. On a problem like that, on a quiz, I would say find the imaginary roots. That way you would at least know that you're going the right way.
Leave it like that, right?
Yeah.
Yeah.
Leave it, yeah.
Can you just say the answers for the other ones?
I don't even know what the other ones were.
12,
12 and 18 and 20, that was it?
Yeah.
Okay. So 12's answer was determine whether that, the first one, x minus 2, well, x minus 2 worked, didn't it?
Yeah.
And x plus 2 didn't.
Yeah.
So it was a yes, comma, no. Number 18, when a polynomial is divided by that. Oh, now, I told you how to do that in class. Is your last term negative 9 or minus 9?
wait, what?
Oh boy. Do you have minus 8 for your last term? Do you have minus 9 for your last term? Do you have minus 7 for your last term? I'm going to tear this up, and it's not even for you. What's your last answer? What's your last term?
My last term?
Share it.
Negative 8. Is there a remainder negative 1?
Yes.
Let's leave it at negative 4.
You add negative 1.
Oh, so then yeah.
So the answer to 18 should have just been 3x to the 4th minus 4x cubed plus 6x squared minus 2x minus 8 minus 1,
Oh, okay.
which is minus 9.
I didn't know what to do with that one. Right.
You add on, you just add on the remainder.
Okay, then I got it.
And then number 20, oh, they're both fraction answers. Interesting. They were negative 1/2 and positive 2/3. How do we feel? Relatively confident?
Better now.
Relatively? Okay. To speed up the notes, because I was thinking ahead as I was doing the homework problems, how am I going to do this? Because these notes could take a long time, but I'm making a video, right? And so if you feel like you need to write down everything that I have posted, like if you feel like you have to write down everything, go to the video and write it all down. But I'm telling you this, you really don't need the first set of notes. When I show you how to do problems, you're not even going to reference the first part of the notes. You'll see. Okay.
So we shouldn't be taking notes off the
Not yet. Don't freak out. Okay? So don't freak out. Don't write this down.
Wait, we can't say graphing.
Yes, you can write 2.3 complicated graphs.
Cool.
Yeah, it's very cool.
Very cool.
No, not really. I don't think it is. I mean, I think it's pretty
I
easy.
don't think it is.
I thought it was pretty easy. All this is just a brain exercise. Your brain needs exercise. I'm giving you that. I'm your brain coach. We don't get to practice our creative side. We get to practice and exercise our like function, crunching, number. This is an interpretive dance class, is it? No. This is weightlifting for your brain. Okay. The only reason that I put these notes on here was just in case you wanted to check your final answers when you're finished. You're not going to understand what this means yet. Don't worry. So all these are just checks. But I'm saying that in most years, most students don't check their answers based off of these notes. So if you want to write them down, you can come to the video later. Oh, look at that. Okay, so this looks like a lot of writing. Don't write it down. You're going to write it down.
You're right.
Don't. So this is just a check. I promise that when we start doing these problems, you're going to be confident enough with your work that you aren't really even ever going to reference these notes, okay? But it's in your book also how to determine if you graph something correctly or not. But I'm saying most of the stuff that we do is going to be like, pretty easy, I guess. Hey, the one thing I do want you to notice off of this slide is that a cubic has 3 answers. And those 3 answers are either like this dot and that dot and that dot, those locations, or this one, and that one, okay? There's just three x-intercepts, right? Got that? So don't freak out about that. Especially don't freak out about cortex, okay? So cortex, they just cross the x-axis 4 times. 1, 2, 3, 4. What? No. You already wrote down the names. Like last section. Or 2 section. Really? Ally, trust me. Cortic crosses it twice, or crosses it 4 times. It makes a W. Now, sometimes Cortic can just cross it twice, and 2 of the answers could be imaginary. So we'll get to that also. But don't over freak out about this. Okay? Here we go. So this slide I could just pretty much skip because we did this almost identical problem on the quiz. How do you graph a parabola? Well, you find the zeros, you do negative b over 2a, you find the vertex, and then you find the y-intercept. Let's do this one. Here we go. Okay, so if I said, let's do a graph for that cubic, and you're like, Mr. Blanchard, it's not cubic. There's no x cubed. Yeah, there is. There's an x cubed. You just don't see it because it's already factored. I did the factoring for you. You're welcome. Later on, you're going to have to factor yourself. Smiley face. That's when it gets fun. So this is very, 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 very simple. The way that you did it last year, hopefully, in He Who Shall Not Be Named class, was more complicated. I'm going to make it simpler. Trust me. Trust me. Here we go. So if I said just graph this baby, just sketch it. So I'm just going to do a sketch. And a sketch, I guess, is different than a graph in that I'm just going to give a rough idea of what the graph should look like. A sketch is just a rough idea of what it should look like. So this guy means -1's a 0. This guy means that 2 is a 0. And this guy means that 4 is a 0. With me? Now, instead of me going back to my notes and trying to memorize those charts that some people were frantically writing down, here's what I'm going to do instead. Ready? All I'm going to do, and you can write this down because this is definitely, if I were to write a math book, this would be in here. I'm going to test a point left of the leftist, that's right, leftist point. I love that sentence. I'm going to test a point left of the leftist point. Nobody. Crickets. That's not. So for you that are not native English speaking, that's not normal English. Just so you know. Okay, so what point is left of the leftist point? -2. That's a great choice. Could I have picked -3? Could I have picked -1,000? Heck yeah. Okay. I don't even care. I don't even care what the answer is. I'm going to test -2. But I'm not going to use a calculator. Here's all I'm going to do. If I plugged in -2 to the first set of parentheses, the answer would be negative. Got that? If I plugged -2 into the second set of parentheses, that answer would be negative. And if I plugged in -2 into the third set of parentheses, that answer would be negative. Well, what's a negative times a negative times a negative? Negative. So it's negative, which means that it starts low. Negative means starts low, starts low. Now, I could totally go back to my notes and see if that's true, or you could just trust the math. Okay, so now it's going to start low. So I'm going to start low here, and I'm going to go through it, through it, through it. Each one changes directions, okay? So it went through it, starting low, then it had to go back down to this point at 2, and it went through it, and then it had to go back up, and it had to go through 4. That's a sketch, okay? So a sketch is kind of what the graph's kind of going to look like. You people now should feel silly that you wrote all those graphs. Shall we try another one? Because this is kind of fun. What? Done. All done. All done. That's sign language for all done. Totally. That's sign language. All done. My dog knows his sign language. We taught it. We did. We taught Mindy. The wonder dog. This means inside. And this means all done. And in fact, we taught even Garrett and Grace when they were real young and they couldn't talk. We taught them, what is it, more? Taught them more and all done. More. Oh, maybe it was this, but we put it up here. We just did more and all done. It's kind of neat and fun to watch little kids doing that. Ready? Set. Did you just say no? Is it bad that when my son, who is now an engineer, he's an architect and a civil engineer, is it bad that when he was like 6 months old, I started doing flashcards with him? I did flashcards with dots on them. And on the back, I had the number. So I would show him one dot and I would say 1, and I would turn the card around and show him the 1. Every day. We went up to 100. Yeah. Yeah. It took a long time.
How long did you do that?
Half a year.
Did you get to 100?
No, no, he couldn't talk.
Oh, you're just saying it.
Oh yeah, I was just showing them to him.
But he really enjoyed that.
Probably doesn't remember.
He loved it.
I bet he doesn't remember it.
Loved it.
You should ask him if he remembers that.
Call him.
Here's all the countries.
I'd probably. All right, let's do another one. Okay. So this is another cubic because there's 3 x's. If I were to multiply it out, it would get an x cubed, yeah? Okay, so we don't have to FOIL, we don't have to do anything. Everything's already been factored out for you. This time it's a little weird because it's a negative x. So even though I did my answers on graph paper, you guys don't have to. Like, you can just make a simple number line and just graph it. Okay, ready? So, oh, can we do a flashback to last year, what you guys had to do? We are. Last year, what you guys had to do was you had to test like -2, but then you had to test like 1. You had to plug in 1, and then you had to plug in like 3, and then you had to plug in 5. Yep. No. Don't you worry. We'll make it simpler. We'll make it simpler. Don't you worry. Okay, so let's go here. So this first one means that 0 is a root. I thought it was -0. The next one is -5. And the one after that is -3. 1, 2, 3. All right, so there's my 3 dots. I'm going to erase this. I'm going to test left of the leftist point, so I'm going to test -6. I'm going to test -6. All right, so it's going to be negative, and then a negative, and then a negative, and then a negative. This negative is that negative. I just dropped it down. I'm not solving it. I don't care that it's 6. I just brought that negative down. This would have been -6, which is negative. This would have been -1, which is negative. And this would have been -3, which is negative. So I don't even care. I don't even want to use the rule. 2 negatives is a positive. Yeah. But you're going to get the same answer. So what's a negative and a negative and a negative and a negative? You're so negative. It's positive. So this one, it starts. Hi. Okay. So here we go. 1, 2, 3. Now you could go back to your notes and you could see what it's supposed to look like, or you could just trust the math. Let's go crazy. Let's do another one. Three, 2, 1.
Are we doing anything other than cubic?
Yeah, we are, but I'm just showing you rules right now. Okay, so the reason I wanted to do the last one, the one that we just finished, was because 0 was a root. And some people would freak out and say, I don't know what that just x means. Okay, so that's why I wanted to do your second example. I want to do this third example because there's something called a double root here. And so there's a new rule for graphing that you need to understand. Are you ready? So if I plugged it equal to 0, this would be this would be 1, duh. And this would be 3. But 3 is a double root, so I'm going to put a dr there. Okay? So I'm going to put a dot at 1, and I'm going to put a special dot, or a bigger dot, at 3, because it's a double root. Are you ready? So now I'm going to test 0. So it would be a negative, and then it's going to be a negative squared, right? So that's a negative times a positive, which is a negative. So it's going to start low. Picking up what I'm throwing down. Okay. When it goes through a single root, it goes through it. When it approaches a double root, it bounces off it. That's the new rule. Bounces off double roots. So it just barely touches it and then bounces off of it. Just goes. Don't believe me? Go ahead and test like you did last year. You could test 0 and 2 and 5.
Yeah,
No, really, you could.
that's all right.
Okay, so that's cool, right? Would you agree?
Yeah.
Not too hard. Now, don't need to do that. Don't write this one down. But really, if I was going to do this problem, I would factor out an x, and then you could factor that into x plus 2 and x minus 2, right? I'm not going to do it, but you could, couldn't you? Everybody should have felt comfortable looking at the red ink up there.
Would you ever have like an X cube?
Yeah. That's called a triple root.
Yeah.
We haven't learned that yet.
Okay, so we're not learning
I don't know. I don't know. I haven't previewed the slides either. But none of this red writing hood, none of this red ink should have scared you, right? There'd be a 0 at 0, there'd be 1 at -2, there'd be 1 at 2. Okay, so now let's see how confident you are. This is a quartic, and I'm not going to do it yet. I'm going to give you time to try it. You know all the rules. You know all the rules. Can you do it? I dare say yes. Yes, you can. It's for you. Do you feel confident doing this problem?
Sure.
Can I interview you for the video?
Go for it.
Hang on. Are you ready?
Yep.
Avery, how do you feel about this problem?
I'm feeling pretty good.
Thank you. Wait, Avery, are you looking at your notes as you're doing this problem?
What do you mean? Like, I'm doing my notes right now, so I'm...
The answer is no. The problems that she wrote down earlier that I said you don't need to write down, she is not using.
No.
There we go. That's going to make for some good audio for the video. Are you ready? Like, it shouldn't take that long, should it? Here we go. You should have had a dot here,
Well, I was being interviewed, so I'm not done.
a big dot here, and a dot there. Big dot is special. How big are we going to make a dot for a triple root? Dang. That would be awesome. Okay, so I'm going to test 0 again. That'd be negative. That'd be positive. That'd be negative. So it's positive. So it starts up, right? And so here goes my graph. 1, bounce, rebound. Did you make a W for winner? Or did you make an M for mediocre?
I'm a little confused how you get like the minus and then positive, or like negative, positive, negative, positive.
Put ones. Oh, just do this. Just put like a 1 here. So even though that's not the value, and this isn't the value, and that's not the value, what would -1 times 1 times -1 be? No, we're all multiplying.
Okay.
But if you want to just think of them being ones, go for it. Did you get it?
Got it.
Good. Okay, so we could go crazy with these problems, like with a quartic. We could even do a quintic. Hey, look, there would be a double root at 0, and there would be a double root at 3. Does that scare you now? Shouldn't, because you're still just going to test whatever the furthest, left of the leftist point. A quintic, there would be a double root at 0, then one at -2, one at 1, and one at -1. We won't do that yet because not everybody's here. And then we won't do that because not everybody's here. Okay, that'll be great. So we're going to start here tomorrow. For tonight, I want you guys to try page 60, I don't know, 66. So now you have enough knowledge to do numbers. I'm trying to, I got to stay away from triple roots because we didn't talk about that yet, but there's a triple root in the problems. Dang it. I want you to try questions 2 and 4, and can't do that one, and 8. And are there any that we can factor? Ooh, 14. One more. So we're sticking with the 5 problem a day. 14 and, let's do 15. I just talked about 15, but I think you can do it. So those 5 problems. To you student council members, I say, good day.